Okay, the equation of the plane is given by x plus 2y minus 2z equals to 18. Relative to an origin, the position vectors of the point A, C, and D are given by negative 2i plus j, 6i plus 3j minus 3k, 2 plus 5j minus 3k respectively. The foot of the perpendicular from the plane A to the plane P is B. Alright, so first one, let's say we talk about the plane A. Point A is negative 2, 1, 0. Alright, this is the foot of the perpendicular. Right, to the plane, and the plane has the equation right. Okay, so this is from in this form. So first one, we want to verify that C and D lie on 18. So actually it's very easy. So we want to verify that your position vector C is satisfy the equation of the plane. So from the question 4, right, you know that your equation of the plane is in this form, r dot 1, 2, negative 2 equals to 18, right? This r represents x, y, z, right? So all you need to do is you sub C inside lor. So C is 633, right? The left hand side you can see, if I sub 633 negative 3, right, dot with 1, 2, negative 2, right, this will actually give me 6 plus 6 plus 6, because negative 3 negative 2 is positive. Okay, so it actually give me 18, which is the right hand side. You can see it satisfies the equation on the plane. Alright, so you can see OC, you can see OC, right? You can see, okay, so OC, you can see that C lies on plane P. Okay, how about the D? D is the same, right? So for the left hand side, if I just sub D, my D is 2, 5, negative 3, right? Dot product at 1, 2, negative 2. This is equals to 2 plus 10 plus 6. Also equals to 18. Right hand side. There you can see that C and D, both of them, I think it's a very easy question. They lie on plane P because they satisfy the scalar product form equation of the plane. Right? So actually since you can say that since both of them, okay, both of them will lie on the plane P. Alright? Okay, next one. Find the position vector of the point B. Right, so basically we want to find A. Remember, B actually is a very typical foot of the perpendicular, the kind of question. So number one, we can either do it by using vector projection, or we can do it by setting up an intersection problem. Right, so first one I can do is by vector projection. Maybe if I were to use a point that lies on the plane. Remember, C itself actually lies on the plane. So if I put C is just 6, 3, negative 3, right? So I'm going to use vector projection. I can say that AC, this is nothing but 8, 2, negative 3, right? AC is just equals to OC minus OA now, OC minus OA, right? That's how I got AC. Alright, the normal vector, happy, sincere normal vector that lies, a vector that lies along this line is just you can find n hat. N hat is none other than 1 over square root 17. Henry, 有用吗？有没有？啊。Okay, 1, 2, negative 2. Okay, so with that, we can just project AC onto the normal vector, the unit, the unit vector of the normal. Alright, so very quickly, AB will just be equals to the projection vector of AC onto, okay, so it's just A dot B hat time B hat. Also it's just remember AC was 823, 82 negative 3, right? dot product with the unit vector of AC okay, multiply by the unit vector of AC again. Oh, sorry, this shouldn't be square root, and this should be 9. Ah, sorry. This should be 9, 1 over square root 9. 2 square plus 2 square, okay, which is 1 over 3, 1, 2, negative 2. So sorry for careless mistake. Then 2, negative 2. Okay, with that, this should give me 8 plus 4 plus 6 over 9. Basically 9 and 9, square root 9 give me 9. 8 plus 4 plus 6. Okay, after that I have 1. Okay, then I have 1, 2, okay, this is just equals to 2 times of 1, 2, negative 2. Alright, so after that I want to find OB, right? What's OB? Remember, we are finding AB. AB gives us the, so what's OB? OB is just equals to OA plus AB, right? Which is equals to OA, as we have given, is that 210 plus 2 of 1, 2, negative 2. So it's equals to 0, 5, negative 4. Okay, that is for OB. Alright. Okay, another way is to set an intersection problem. So it's like something I've done earlier in question 2. So hope you can also take a look at it. Okay. Part 3. So for part 3, find the vector CA prime. So A prime is the reflection of A about the plane P. So if we look at this, okay, so actually let's say if A, right, is a reflection of plane P, so probably if I go underneath, right, so let's say if I draw a solid line, I draw a solid line, if I go underneath, right, I use right, so underneath I use alright, this will be A prime. Alright, so what I can do is, if I want to find CA prime, right, basically, okay, so this is let's say if I look at this is CA, and then this is CA prime. Alright, CB, as we know, okay, you can see CB, CB lies on the plane. Alright, and CA prime, okay, what can you think about? Okay, you can see, if I were to just pull out the triangle here, you can see this is A, this is A prime, this is C, this is B, right? What can I do? If I ask you to think about the ratio 1:1, right? So what can I do? I can simply use ratio theorem. That's one way. Okay? So very quickly, CA will just be, this is AC, right? So CA is just negative 8, 2, positive 3. Okay, so CA prime will just, remember, okay, CB is just equals to CA plus CA prime over 2. Okay, CB, okay, this is just OB minus OC, right? So OB is equals to, as we found in part 2, is 0, 5, negative 4. OC is nothing but 6, 3, negative 3. So this will give you negative 6, 2, negative 1. Right? So that means your CB, negative 6, 2, negative 1 is equals to 2 times of CA. CA would just be what you found just now, will be equals to negative 8, 2, 3 plus CA prime. Okay, from here you should be able to find your CA prime, and CA prime will finally be the answer, negative 4, 6, negative 5. Okay? Yep. So next, hence or otherwise, find equation of the reflection of the plane ACD about the plane P. Reflection of the plane ACD. Okay, where is D? Remember D? Where is D? You're thinking, oh, D actually is also a point that lies on the plane, right? Correct or not? So remember, D was somewhere, probably somewhere here. D is nothing but the point it was given. So D is the point 25, -3. Okay, so D, C, and A. Remember that D and C lies on the plane. So we're actually looking at this DCA prime. We're looking at DCA prime. DC, right, C and A prime. So this is my C. My C is here. Okay, -3. Okay, DCA prime. How do we find the equation of the equation of the reflection of plane ACD? Right? ACD, you can say if ACD, this is the ACD, right? ACD is actually here. What if I reflect it? Actually, I'm going to get the DCA prime, right? Because you see, I reflect. This is what I get. Okay. So it's not easy to see this. It can be quite a challenge. Okay. So this is basically the plane that I'm getting, DCA prime. How do we find the equation of DCA prime? So if you go back just now, right? Remember DCA prime, DCA prime. Actually, it's very easy because we can easily just find DC. We find one vector. Okay, okay, maybe let's find CD. What is CD? CD is just equals to OD minus OC. Alright. OD, as we have found, is 25, -3. OC is 63, -3. Just equals to -4, 20. So one vector here, one direction vector that lies on the plane is -240. Can I find how about CA prime? I can also find CA prime, right? CA prime, as we found earlier, is a -4, 6, -5, right? With these two, right, I can actually straight away come up with the equation of the plane. So what I do is I'll take these two vectors that are parallel to the plane, and I'll find the normal. So what I'll do is I'll take these two, and then CA prime, okay, cross with CD, which is -4, 6, -5, cross with -4, 20. Okay, eventually you are going to get 2 times of 5, 10, 8. Right, so the normal to plane A prime CD is just equals to 5, 10, 8. Alright, and after that, I can take any point on the line. It can be on the plane. Maybe I can just take OD. OD, remember, this is a point on the position vector with the point D that lies on the plane, right? And very quickly, using R dot n equals to A dot n. Alright, our n, as we have found earlier, is 5, 10, 8. This is 5, 10, 8. The plane A prime CD, right? I can choose just any point. Maybe I choose D. Okay, and I choose this is 2, 5, -3. Okay, so if I dot product, this will just give me R dot 5, 10, 8 equals to 10 plus 50 minus 24, which is equals to 36, and I have R dot 5, 10, 8 equals to 36. And that's the answer for part 4. Okay, so is part 3, sorry. So we must be able to see that the reflection of ACD. CD is actually a line that lies on the plane. So I reflect. Okay, I'm actually finding plane A prime CD. That's the plane that I'm finding, the equation that I'm finding.